Discovering cyclones, the power of nature. Cyclones are one of the most powerful natural events on Earth. Imagine winds so strong that they can lift roofs off houses, waves taller than buildings, and rainfall so heavy that entire towns flood. Cyclones are massive storms with low pressure at their center and spinning winds that rotate in different directions depending on the hemisphere. In the Atlantic, we call them hurricanes, in the Pacific, typhoons, and in the Indian Ocean, simply cyclones. These storms can stretch hundreds or even over 1,000 kilometers across, and their strength is measured using the Saffir-Simpson scale, which ranks cyclones from Category 1, which is mild, to Category 5, which is catastrophic. But how does a cyclone form? Cyclones begin as clusters of thunderstorms over warm ocean waters, usually above 26.5 degrees Celsius or 80 degrees Fahrenheit. Warm, moist air rises from the ocean surface, creating an area of low pressure. As this air rises, it cools and condenses, forming clouds and rain. The rotation of the Earth then causes the storm to spin, a process known as the Coriolis effect. If the conditions are just right, warm water, plenty of moisture, and low wind shear, this system can grow into a powerful cyclone. In essence, cyclones are enormous engines, fueled by heat and water from the ocean. A cyclone has several distinct parts, each with its own role in the storm's power. The eye is the calm center, often clear with very light winds. Surrounding the eye is the eye wall, which contains the strongest winds and the heaviest rainfall. Beyond the eye wall are the rain bands, long spiraling bands of clouds and rain that can stretch over hundreds of kilometers, producing heavy precipitation over large areas. Understanding these parts helps scientists predict which regions will experience the worst effects and prepare accordingly. It also helps students understand why cyclones are so different from other storms, such as tornadoes or ordinary thunderstorms. The intensity of a cyclone is measured based on its wind speed, damage potential, and storm surge. The Saffir-Simpson scale classifies cyclones from Category 1, with winds between 119 to 153 km per hour causing minor damage, to Category 5, with winds exceeding 252 km per hour and causing catastrophic destruction. Category 3, 4, and 5 cyclones are especially dangerous, capable of destroying buildings, uprooting trees, and flooding entire coastal areas. Many cyclones around the world have shown just how destructive they can be. Hurricane Katrina in 2005 caused massive flooding and devastation in New Orleans. Cyclone Nargis in 2008 killed thousands in Myanmar. Typhoon Haiyan in 2013 was one of the strongest storms ever recorded, devastating parts of the Philippines. Each of these events reminds us of the raw power of nature and the importance of preparation. Cyclones are dangerous because they bring multiple hazards. Strong winds can demolish houses and topple trees, turning debris into deadly projectiles. Storm surges, caused by ocean water being pushed inland, can flood coastal communities within minutes. Torrential rains can trigger flash floods and landslides, while some cyclones even spawn tornadoes as they move inland. The combination of these effects makes cyclones among the most destructive natural disasters, which is why understanding them is so important for safety. Meteorologists use advanced technology to track and predict cyclones. Satellites in space monitor storm formation and movement, while radar systems measure rainfall and wind speed. Computer models simulate how storms develop, allowing scientists to predict the cyclone's path and intensity. These early warning systems are crucial, giving communities time to evacuate, protect property, and reduce loss of life. Over the years, advances in science have greatly improved cyclone forecasting, saving countless lives. Cyclones also affect humans and the environment in profound ways. People living in coastal regions, often forced to evacuate, and homes, businesses, and infrastructure can be destroyed. Crops may be ruined, leading to food shortages, and millions of dollars in economic damage can occur. Wildlife is also affected. Birds, reptiles, and mammals may lose their habitats, and coastal ecosystems can be altered by flooding and storm surges. Surprisingly, cyclones can also benefit the environment by redistributing nutrients, replenishing wetlands, and creating new habitats for some species. They are a reminder of the balance of destruction and renewal in nature. For students, learning about cyclones provides insight into Earth's weather systems, the science of prediction, and the importance of disaster preparedness. Understanding how cyclones form, how they behave, and what effects they have on people and ecosystems helps students connect science lessons to the real world. Cyclones demonstrate the power of natural forces and the need for careful planning, safety, and respect for the environment. In conclusion, cyclones are both awe-inspiring and terrifying. They are massive displays of energy, fueled by heat from the ocean and shaped by the Earth's rotation. Studying cyclones teaches us about weather patterns, Earth's systems, and human resilience. By learning about these storms, we gain knowledge that helps them understand not only meteorology, but also how humans can coexist safely with natural forces. Cyclones may be powerful, but knowledge, preparation, and science help us protect lives and communities. If you enjoyed this journey into the world of cyclones, make sure to like, subscribe, and share this channel. Stay curious, stay safe, and join us for more science adventures exploring the wonders of our natural world.